Now, an interesting thing happens when you take Tylenol for a headache or you take an antibiotic is that your body gets rid of some of the drug, but not all of the drug. And so if you were taking Tylenol and it says take 2 pills every 4 hours, what happens is if you take, say, 1,000 milligrams of a drug, and let's say after 4 hours, half of it goes away. Your body might get rid of half of it, but half of that drug is still in your body. So after 4 hours, you still have 500 milligrams, you still have a little bit of a headache. What do? You take 2 more pills. Now you have 1,500 milligrams in your body. The same thing will happen is in 4 hours, your body will only get rid of half of it. So now you have 750 milligrams in your body. You still have a headache, you take 2 more pills. And now your amount in your body is 1,750. And 4 hours later, your body will get rid of half of that again. And this will continue on and on until it levels out. Eventually, your body will have 1,000 milligrams in it. And if you took 2 more pills, that would put you at 2,000 milligrams. But when your body gets rid of half of it, it's back down to 1,000. And you'll never go past 2,000. Unless you take 3 pills, because then you get to those places of overdose. So the question is, well, why didn't I start with 4 pills? Because then I could be at the maximum. Well, that might cause a shock to your system to have that much in it at once. So it slowly builds up. But it also means that once you stop taking a drug for a headache, even though 4 hours pass, you still have stuff in your body and it still affects you. And then 4 hours later, there's still a little bit. That's why they can do drug tests to find out if an athlete has steroids, because there will still be a trace of it left in the system.
So are you saying when you do a drug, like, and no matter what it is, you only get rid of half of it, so technically you'll never get rid of the amount in your body?
For those ones that get half of it taken out, theoretically, there will still be such a minute trace. But eventually, just like when I dropped the golf ball the other day, it's so minute that it can't be picked up anymore. Okay. So here we've got a person taking some tablets to cure a chest infection. There's 500 milligrams of an antibiotic. And 15% remains in the body when the next tablet is taken. So if you take 3 tablets, well, let's start off by just making a table to see what happens. When you take your first tablet, how much is in your body? 500. That's what's going to happen. Then when you're about to take your second tablet, you're going to, this is your second tablet, it's going to be another 500, plus how much is left of the other one? Okay? If 15% remains, only 15% is left. For this antibiotic, your body had gotten rid of 85%. So if we do 15% of 500, that'd be 0.15 times by 500. Now when we get to our third tablet, well, you'd be adding 500 because that's your new tablet. Your second tablet plus what you had before, there's only going to be 15% left of that. Now I'm going to do this in 2 steps because I'm going to first say, well, if I do 15%, 0.15, of my amount in my body of the second tablet, that would be 500 plus 0.015 times 500. Are you okay with that? In that all I did here was this part here was how much I had after the second tablet. That's how much was in my system. And my body is going to keep 15% of that. So now if I distribute that 15%, I would have the 500 plus, now this 0.15 would get multiplied by that 500. And this 0.5, when it gets distributed over to this one, can you see that I would have 0.15 squared times 500? By the time I've written my third tablet, can you see that it's making a geometric sequence? And adding them up is making a geometric series. In my geometric sequence, what's my term 1? 500 is my term 1. When I look at my second term and then my third term, what is my R value? My R value is 0.15. And if I wanted to find out how much is in my system, well, the first tablet, this is really the sum of the first one. This is the sum of the first two, and this is the sum of the first three. If we typed it in to our calculator, we would find out that this is equal to 586.25. And you can see really why it's helpful to notice this pattern, because to find 10 tablets, it would be a really long thing to write out. If we wanted to keep the pattern going to find 10 tablets, this would be quite long. But if we notice that it's just a geometric series, we can now figure out that after 10 tablets, that's going to be the same as S10. We know term 1 is 500. We know that our R value is 0.15 to the power 10. And if we type this into our calculator, we get 588.2352975, and if we round that, approximately 588 to the nearest gram. Does it say how much we should round to? Does it? It doesn't tell us how much to round to, so we could, at the bottom they have it rounded to 2 decimal places, 588.24. or close to 588 milligrams. And after 10 tablets, this is probably when it's getting close to stabilizing. In fact, if you put in a very large number, you would really get to see how close it is to stabilizing. So I'm going to, oops. Couple of things that are neat with your calculator. If you type in 500 and then 1 minus 0.15 to the power of 10. Whoa, I wrote 41. I don't know why. One minus 0.15. There's the answer that we just figured out. Now with your calculator, a couple of options that you have. What you can do is you can push second and enter, and above it in blue letters on mine it says entry. Yours might be in a different color, but if I do that, it retypes what I just typed in. So I could go back and say, I want to see what happens if I took 100 tablets. What would it, whoa, that zero's in the wrong spot. Let's go up. There, 0. Delete that one. What would happen if I took 100 tablets? How much would be in my system? 588.232941. Just a tiny bit more. In fact, we can see that the drug is already stabilizing in the body. So this drug, they would know what's happening and how your body reacts to it, and they would set it up so that it's not affecting you in an adverse way. That's why they tell you how much to wait and how much you can take at those times. So kind of an interesting biology and math connection in this one. Questions you can do that are related to this. Number 12.